Okay, so we're going to be doing, out of chapter 13, which is for Z transforms, we're going to be doing 13.2, part 5. And the problem we are given here is x of k is equal to k times u of k. And what we are asked to do is to find the unilateral Z transform. Now the difference between the unilateral and the bilateral Z transform is that we're only looking from k from 0 to positive infinity, as opposed to the bilateral, in which case you will be looking for k from negative infinity to positive infinity. Okay, so we're going to start here, and we're just going to use the formula that was stated above, and x of k times z to the negative k. So our x of k here is k times u of k, and then times z of negative k, just part of our formula. Okay, so here we have a little bit of redundancy, you might have noticed. So we're starting from k equals 0, and we also have a unit function here. Now that's kind of redundant, so in this case we will just simplify that. Right, it's a summation positive infinity, k equals 0, and then it's just going to be k times z to the negative k. So this is already looking pretty nice here. Now the goal for Z transforms is to get it into a format that you can easily recognize or apply to a geometric series. Here we're pretty close. We're just going to make one more change, and just to recall here, so for the geometric series, n times r to the n is the one we're going to be looking at, because as you see here, it's very close to what we have. We just have to make a few slight adjustments. So if we have the summation from n equals 0 to positive infinity n times r to the n, the answer would be r over 1 minus r, and that's supposed to be squared there. Okay, and then the region of convergence would be absolute value of r is less than 1. So we're just going to make a little modification to r's, and you'll find that it's very easy to work with. So k times z, and we can do this is algebraically, okay, z to the negative 1 times k. So then we have an easy to manipulate n here and r here and n again up here. So what we can do is we can plug that into our geometric series. So here, like I said, just to reiterate, to make it a little more clear, this is going to equal r, k is going to equal n. So then we can plug it into our geometric series, and we say that x of z is equal to z to the negative 1. So this is our r on top, and then it's 1 minus r, the whole thing squared, and then the r in this case is going to be z to the negative 1 again, the whole thing squared. And for Z transforms, you're not quite done yet. What you need still is the region of convergence. Now, conveniently, we were given the region of convergence for this geometric series, so all we have to do is say that the absolute value of Z is less than 1. Absolute value of Z to the negative 1 is less than 1. And that is our region of convergence with the unilateral Z transform.